So, just real quick for the recording, we are starting chapter 3. It's going to be a lot of exponential type stuff. Some good stuff in this unit that I really, really like. But today's objectives, they're there. I'm not going to reread them for you. You can pause and read them if you're on the tuba U. So, exponential functions. Exponential functions, f with a base of b are defined as such. Please make sure you make a note of that. All you're looking at here is in function notation because of the f of x versus our old equation notation. But of course you guys know they should be interchangeable, right? And sometimes you will have to, if you want to evaluate something, you're going to want to switch that f of x for just some variable that you can manipulate much easier than the idea of f of x. B does have to be positive, and it has to be a number other than 1. It has to be greater than 0. It cannot equal 1. You have any ideas why it would be 1? Why it can't be 1, I mean?
Oh. What's that word? It wouldn't be exponential.
It wouldn't be exponential? How so? It's still in the same form, right? If I did y equals 1 to the 5th.
It's still 1.
What? That's 1 also?
Yes.
What if it was 50 seconds?
It's still 1.
That's still 1 too?
Yeah.
So, it's also 1. So, thank you. Fantastic. So that's why it cannot be 1. Otherwise, you won't have an exponential function. You'll have a horizontal line over here at 1. Okay? And of course, we're looking for that bend in this case. And of course, it can't be 0 because 0 to any power is still just 0 again. Which is kind of interesting. You can be anything between 1 and 0, or you can be anything above 1. You just can't be 0 or 1. Okay? All right, can we change the slide? No.
But it's positive, right?
Yeah. Does it have to be positive? I'm going to say no. It doesn't have to be positive. But for now, let's just stick to this rule where b has to be greater than 0 and it can't be 1. Okay? Because some special things happen when they're negative. Are we good with this slide now? I can change it? Yeah? All right. Let's take a look at what this guy bad boy said. All right, let's start doing this right away. The exponential function f of x is equal to 42.2. Thank you for not talking while I'm talking. I have a cold and I don't want to yell. It hurts my cabeza. So anyways, the exponential function right up here, 42.2, multiplied by 1.56 to the x, shows us that this is going to be exponential. It models the average amount spent, which is f of x, in dollars, at a shopping mall after x number of hours. So, many husbands know you take your wife and you leave them in the mall. The more longer you leave them, the more they spend, right? So
okay, let's go after 20 minutes.
The question, that's me. I don't even like stepping foot in there.
Why you just don't go?
What is the average amount spent to the nearest dollar after 3 hours at the shopping mall? Well, they've given me the model already, right? What is that model? The model is 42.2, 1.56 to the x. And x represents the number of hours. We're looking for 3 hours. So I'm just going to use my calculator here. 42.2. And then I've, oops, wrong way. That way. And that way. And what was the other value? 1.56. And if you want to do an exponent, use this caret button, and it'll make it an exponent. And we're evaluating at 3 hours. Hit that enter. Boom. How much you spend after 3 hours? $160.
Why couldn't it be like times 3? Like how would you know that it would have to be exponential?
Because they told us it modeled that.
Yeah, they gave us
So they're saying, hey, you know what? This particular person, whoever shops there, the longer you go there, the more they're going to spend, and then the faster they're going to spend it.
Wait.
And they told us that was the model. Now, if your shopping situation was different, where it could have been a multiplication type thing, because technically this really is, but we're multiplying at a faster rate. Because we're taking this 1.56 times itself 3 times. And that's what an exponent really means, right?
Yeah.
So you're just doing it much faster, you're spending more money. So it kind of is. Okay. What did we say it was? $160. And a few cents, right?
21 cents.
And 21 cents. Can't forget the change. Would you like to round that up? I remembered right now.
He came to visit me at work and I was like, do you want to donate $1? It's like, you want to round up?
Oh, it wasn't round up on yours? Some people say, would you like to round up to $1?
Usually you're supposed to ask if you want to donate $1 first. If they say no, then ask if they want to round up the change.
Oh, first it's $1, then it's a change. And it's like, stop harassing me. What's the 21 questions?
I know this.
A lot of people just, a lot of the cashiers that I go to just say round up.
All right, so we're good? All right, changing the slide then. Now, here's some. Thank you. Thank you. Here's an exponential function. F of x is equal to 3 to the x power. You should be able to graph these, right?
Yeah.
And the old primitive way, there, Maya, is by just plugging in numbers, just picking a few, okay? So you can pick a few positives, pick a few negatives. They'll give you the most important part, which is the bend there. And then, of course, you just try to fit a line through those. I should say a curve. Try to fit the curve that fits through there, right? And if you need more points, then guess what you should do?
Plug in more.
Plug in more points. Sorry, I should say, if you want more coordinates, more graph. Well, technically, that's what they are. Each one of these points is a graph, isn't it?
Yeah.
And then the full graph is just a collection of all those points that just end up stacking up on top of each other. They give you the general shape. So if you want more graph, well, coordinates are simply directions,
Oh my gosh.
right?
Okay.
But isn't that what it is?
No. Like the coordinates to this graph are going to be what we'll say 1, 3. Those are the coordinates to the graph. It's like saying, hey, you know what? I want to go to Fry's. You don't say, oh, just, being at Fry's doesn't mean that you're going to go up the street and then make a left, right? Those are the directions to get there? No?
It makes sense.
But okay, that's fine.
It's not even that big of a deal, but
Well,
something I wanted to insist on saying there. Characteristics. So here's what I was talking about. Notice that you have this blue curve up here, right?
Yeah.
That blue curve is where all of your b values are greater than 1. Where they're all greater than 1. If your b values are between 0 and 1, then you're going to end up with the red curve. This is what the values that are between 0 and 1 look like. Blue one is all the numbers that are greater than 1. Questions on that? What are the domains here for either one?
negative infinity and infinity.
What about range?
Parentheses
0
0
to infinity. To infinity.
You have a cold?
Yeah. I've been out hawking junk all day. Yesterday too. I haven't had one of those nice ones when you sneeze and so much junk comes out when you sneeze.
Ew.
Oh. Those are the good ones.
Don't move. Because it's coming out of your nose.
You know what? It's better than coming out your body than staying inside.
No, it's coming out your mouth. Wait, what was range again?
Oh, the gust of fresh air? I knew you were talking about. Okay. Thank you. Thank you very mucho. Okay. Again, here is 3 to the x. Just like all the other functions, they all behave the same way, except for the line. We have weird names for the lines. But remember we talked about the transformations. There's A, H, and K, correct? You're going to be able to apply those same things here. Here we have an exponential function. Notice where my x is at. It's up at the top, right?
Yeah.
Technically, it should be like a parenthesis inside of here. So that is still x minus h. That means that there's a transformation going on, right? So is this a vertical shift or a horizontal shift? It's a horizontal shift. It's x minus h. It says minus 1. So I go to the left one, right?
No.
What?
You go to the right. You're me and math. What?
Yeah, go to the right one. Good job. So there's my point. And should that be the only point that moves 1?
No.
No, they should all move over 1. So that guy should be there. Did I miss one?
No.
This guy should come here. And so forth. So you're going to get a curve that kind of looks like... Okay, questions on that?
No.
Super stuff that we've already done. If I did want a vertical shift, what would I have to add to this?
Plus.
If I wanted to move up, I would add a k at the end, right? I'm going to go ahead and write it down here for you guys. What's the generic form of this bad boy? A times b to the x?
Yeah.
Oh, look, there's an a there already. Minus h plus k. Okay?
Oh, so
And then A is the one that like makes it like, oh, it flips over the X and X is right.
Think about it. Remember I kept this a slopiness?
So
Stretch,
that
compression type thing?
Yeah, I don't like
And
that.
that one also.
So if it was a negative stretch, would it go down?
No, and that's what's interesting about, well, I know what you're saying. I'm glad you said that because that is a really good question. Okay? His question was, if I had, let's say I did 3 to the x, okay? Obviously we already saw that, right? It kind of did something like this. And they all look very similar. But the idea we want to talk about is, well, how do I make it go the other way? How do I make it go this way?
It'd have to be a negative, wouldn't it?
What? What has to happen?
B has to be less than 1.
It has to be between 0 and 1, right? So if I want it to be the red one, then I need something that's between 0 and 1, something like
1/2.
1/2.
Yeah.
So this would be 1/2 to the x. Does that make sense? Okay. Now I want to make a point because you kind of said that to us, right? If I did, let's see here, this. What's going to happen here? Turn to your neighbors, talk about that.
Wait, what? So if it's negative, don't you take the reciprocal and turn it into the axis? Oh yeah, because the yeah, exponent would be negative, so then you turn it into a function. What? I said it before you were saying.
So you can make it like
It's gonna be interesting. Maybe. I don't know.
Ah.
it means you're right.
I curse you, statistics.
Become a fraction.
Okay, so there's our y to the 1/2 x. Somebody want to share with me how this is gonna change?
All I know is that it takes the reciprocal.
It's gonna be reciprocal.
So it's gonna flip it?
Yeah.
So it'll turn it into like one of these black lines?
Yeah.
This one right here?
No, it'll turn it into the red line.
No.
Yeah, when it turns to the red
So
line.
this here's our red line, right?
Yeah,
So if we did this,
it would turn to the red line. Because you're gonna take the opposite of that to make the x positive.
all right, let's check it out. So this will be
Already
2 to the
Negative x.
negatory x. I feel like I'm gonna sneeze.
Bless you. It's the same thing.
So there's our blue line, and then here comes our red line.
It's gonna take the reciprocal of 2, so that way it makes the x positive.
why, right? Is the question? So let's think back to some rules of exponents. That's why I wanted to address this because you kind of brought it up. It's a really cool idea. How do I get this? How about some professional courtesy here? We're going to touch. Thank you. How do I get this negative to become a positive? I would have to take the reciprocal of the 2, wouldn't I? So is that not the reciprocal of 2?
Yeah.
And that's the positive now version of it? So same idea. Those are the same thing. I just use some exponent manipulation.
Sure. I think
Some of the power rules from last lesson.
my
What's up?
question was, what if A was negative?
What if A was negative?
That would be
Well, you tell me.
that'd be a reflection over the
X-axis.
x-axis.
That should be a reflection over Y, right?
Why?
Because you're changing. This is Y.
This is why.
Y is equal to the function, correct?
Yeah.
That's true? So I'm taking all of the positives and I'm going to make them negative. So if all the x's or all the values are on one side, I'm making them jump to the other side now. And if they are on the other side, or on the negative side, I'm making them jump to the positive side by doing that.
So what if it was negative?
So let me show you that real quick. So I'm going to go back up here, and I'm going to go ahead and, you know what, I'm already there, so I'm just going to insert. Is that cool with y'all?
Yeah.
I'm going to insert a negative in here. And then let's graph that real quick. So we should get our first function. Oh, wait a snap, it did flip it. Oh, wait a minute. Yeah, parabola. My bad. Yeah. You guys were right. I was thinking the wrong way. How do I make it flip left to right?
Negative A.
Not negative A. Left to right, not up down.
It'd be a negative B, wouldn't it?
Yeah. My confusion, my bad.
Oh yeah.
That makes it happy or sad, doesn't it?
Yeah.
My question is though, how do I make this guy, the red one, flip to the black one? What would have to be negative? The x would have to become negative. Because then I'm changing the x's from being positive to be negative. I dropped the ball on that.
Yeah, I know the first
Yeah.
one was that way. So if the A part is negative, it's kind of.
So let's go back in here. Let's delete this. And then my x would have to become negative. Now, is that going to work?
Yes.
Is that going to work? Second, am I inserting right now?
Yeah.
Well, you have to do the reciprocal.
No, if you do it that way.
Is that going to work? Is that going to flip it?
Yeah.
Left to right.
Yeah, flip it.
Here's our first line. And come on up.
Yeah, it flipped it.
There you go. Why though?
Because it's gonna take the reciprocal.
Well, there's two different reasons. I guess you can think about it two different ways. One, we know that that's a reflection on the y-axis, correct?
Yeah.
But also, I can think about it as I had y to the 1/2 to the negative x. Do I want that to be negative?
No.
I would have to make it
Positive.
positive, which means I would have to flip this, wouldn't I?
Yeah.
Which now gives me this, which I already know rises to the right.
Yeah.
Rises to the right, yes. Okay? A lot of side note there. Thanks for the question. Good conversation. Can we change slide now?
Yeah.
All right. E is called the natural base E. The natural base E. Okay? Anybody know the formula for this bad boy?
Nope.
Here you go.
Yeah.
The
What is that?
it's just the top piece right here. It's 1 plus 1 over n to the nth. That is the formula to get E. Now, does anybody recognize that part of that formula
Yeah.
as
I don't know, but I know it.
N.
compound
N.
interest? You guys remember compound interest?
No. I just remember N.
No. Your formula was y equals, what is it, principal? Sorry, it's not, what do they call this? Not principal, they call it the, let's call it the balance. Balance is equal to the principal plus 1 plus r over n to the nc. Something like that?
I don't even remember that. So.
I want to say that's the formula. Well, look at this. Ignore the t for now. Ignore this t for now. Okay? And if this is a 1, then you have the same thing up there, which is where base e came from. I know, I changed it. But because it has bases in that, and that's where this part from our compounding formula came from. Okay? And I'll tell you right now what it means, okay? So everyone's okay with this? And e is approximately, it's not a rational number either. So when you think irrationals, it should be, e should be in there, okay? What do we call it again? Natural base e. Yeah, we call it e. Because then there's something else called the
Natural log.
natural log.
Yeah, and that's where I got confused. I knew it was a natural something.
Hold on.
Natural exponential. That's me when I don't want to go to school, like mom.
I really thought about calling in today.
I should have played the super card today.
Yeah, we have a good stuff. That's good.
You will soon.
Why?
I'm going to go observe teachers at other schools.
Just like
My mom is taking her test to be certified.
Awesome.
I really hope she passes.
Okay.
Like,
You know what? I think we skipped something, so I'm going to go back and I'm going to talk about it anyway. This is going to be probably some type of intro into compound interest. Okay? And compounding just means that they're going to add interest to your account based on that compound number. So they can add interest to your account yearly. And usually these numbers have to do with a year, okay? So if you said yearly, then how many times are they compounding your account? Once. Because they do it every year. If they were going to compound it semi-annually,
Oh.
then you would be doing it
Twice.
twice. If they were doing it quarterly,
It'd be 4 times.
quarter being 4, right? Quarter. Then they could also do monthly, so they'd be 12. They
I
could
remember
do
this
it
at the very end of the
weekly,
year.
which is 52. So we started off with yearly. I'll just do year 1. Then we have semi-annually. I don't even know how to spell it. That'd be 2, right? And then what do we do next?
Quarterly.
Quarterly. 4. What else?
Monthly.
Monthly.
12.
12. Then we could do weekly,
Weekly,
which is 52. We could then do
daily,
daily,
which is 365.
365.
And
Um,
semi-daily.
Well, there could. I mean, you can see that there's a bunch of options, right? We could even go from daily. We could go to hourly,
Yes.
right?
I don't know how many hours there are in it.
Yeah, I'm not too sure either. But we can go from hourly. We can go to half hours. But then we can jump to
Holy crap.
minutes, seconds,
Milliseconds.
milli,
Uh,
right? So
Don't do that. Because
here's one thing that I don't know those numbers, but I'm telling you that they're going to be bigger than the last one, right? So these numbers get bigger, 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 bigger.
Yeah.
We're also going to do something called continuous compounding. Continuous compounding.
I hate that one, I think.
So when we talk about continuous compounding, it's the same thing as this, except are they doing it yearly? Are they doing it daily? Are they doing it hourly?
No.
No, it's continuous. Like as soon as you got it again, again, and again, and again, and it just rolls over, one right after the other. It never stops. It just keeps doing it. I wish I had one of those accounts. Gaining interest continuously, because you would be gaining interest like it just doesn't stop. Okay, and that's an idea that we have in math. This idea of compounding continuously, just keeps growing. Okay, so that's what our E is going to be for. Everyone cool with that?
Yeah.
Cool beans. Now, does somebody actually remember the formula
No.
for continuous compounding? Oh, look, there it is. Here it is. Hey, I was right. A is equal to. I was completely right.
It was completely right. No?
Oh, I put plus. You're right. It is P times. And that should make sense because this principal is going to grow by its original amount and then whatever percentage more. So here's your original one. Okay? And then down below is the formula for continuous compounding. It looks so much more simpler, doesn't it?
Yeah, I remember it. It was a lot easier.
But it's exactly the same thing.
I remember this.
I don't know why it was easier.
How is it exactly the same as before?
Don't ask.
Because E. Do you guys remember what I said about E? The formula for E is 1 plus
Oh,
1
it's
over
that.
n to the n, which is this piece. Well, sorry. Well, it's most of that piece. But there's already the n there. And all we're really doing is adding the RT to that. So all that's already being calculated for you, which is this piece. And that number is simply 2.71, blah, 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 blah. So they're the same formula, except they've done some math for us, which is E already. Yeah, that's how I remember it, APERT. Okay? You guys see the connection there between those two formulas?
Yeah.
So it's exactly the same, except here we get to the point where we're just continuously compounding, so we can bump that whole 1 plus R over N, and then just plug in the E. Thank you for putting your cell phones away. Oh, I thought you had, because you got a big old, something's going on with your hair.
It looks like a waterfall.
Thanks, Tiki Winky.
She's a little banana from Ice Age.
Teletubby,
Oh,
bro.
you do.
You look like that Teletubby with the...
You look like that Mexican kid.
You ever seen Teletubbies? No, when he does let the girl the sloth, whatever the thing is, I
Yeah, we get it.
That's cool. Hey, I get it, right?
You get the joke.
All right. Questions on this slide? Can I change it? There are questions? Oh, okay. There is none, so I can change it. All right, let's try this out then. A sum of $10,000 is invested at an annual rate of 8%. They wants to find the balance in the account after 5 years, subject to quarterly compounding. You guys want to try?
Yes.
Go ahead and try.
No.
You already have your formula. You've already got your formula. Your crusty crab formula.
That's so
Stop.
The periods per
Yes. Is it RT
Yeah.
or is it NT?
No, it's RT.
NT.
Oh, it is NT.
Yeah, because number of times.
periods per year.
Oops, it's not 5,000.
8%. Oh, I think 8.
There,
Yeah, I knew that. I knew.
that's the 4 is the N.
Okay. That's what I thought. Wait,
Oh,
where's the 8?
oh, 8. They will go above the 4, wouldn't it? Wait, so it should be.
Wait, so P stands for principal, right?
Yeah.
And T is time?
Yes.
Oh, okay.
Is this right?
Yeah.
Why is it not like, why is the...
I just find it.
Why isn't it 0? Why isn't it 0.08?
I was hoping people would answer that next.
Got it.
Please do not make this mistake.
Can we put E instead and then fill it from there?
No, because this is not being continuously compounded. This is being done quarterly.
Okay.
Now, if they say continuous, and that's a very specific problem, and they'll tell you. So whenever you see this is done specific or continuously compounded, then you want to use the other formula. Otherwise, you're using this bad boy. Marner.
Just for T.
Oh, yeah.
You're saying that the rate is the 0.08?
Yes. Please make sure that you don't make this mistake. A lot of people that get it wrong is because you forget to convert this 8% into a base 10 number, I guess you could say. It's got to be in a decimal form, okay? Otherwise, you won't get it right, or you won't get what you're looking for. Now, just a heads up. This 1 right here is including your original 10,000. If you drop that 1, it will only give you the percentage of the increase, like how much more you have in interest. Does that make sense?
You have to add it on.
Right, then you would have to add it on. So don't forget the 1. It just makes it easier this way. You do it all in one step. But if they just ask you for the interest alone, then you can drop that 1 because that will not consider your principal.
Okay.
I believe you. No? That's from Beetlejuice.
Beetlejuice.
Okay, I believe you.
Oh yeah.
Okay. Oh, now I got it.
That's a great song too. Yeah? Yeah, go for it. Alright, so what do we get?
I got
14,959.47.
Good. Can I get someone else? I already got 2 people.
14,599.
Alright. Let's go. Now. Oh. One more time, someone. 14,000?
859.
859?
Yeah, 0.47.
Approximately?
Yeah.
Because it only gives you so many.
Do you ever just like bump to music in your head and you're like,
Yeah, all the time.
see, people look at me weird when I do that, but I'm like, I get in a good mood and I like to just put one song.
P is going to be your principal amount. R, yeah, R is going to be the rate, the AKA interest rate. N is the number of times you compound. Number of compounds, and it does show up twice. And then T is time in years.
So if it doesn't mention anything about like
You should be able to decipher all of that from the problems.
So if they like give you like say 6 months, you still have to convert it to years.
Yeah. Yeah. So if they told you you're only doing it for half a year, or for 6 months, like he said, you're only compounding for 6 months,
Oh.
then that time in years would have to become a 0.5. Because it's only half of a year. See how here they said 5 years? If they told you it's only being done for 6 months, well, 6 months is half of a year, right?
Yeah.
So T would have been 0.5. Because remember, T is in time and years. I will not. I shall leave it. Really? I can change the slide now? No. Okay, I believe you. Good? Anybody else? You still need this slide? Going. You alright, Joseph? You okay over there? You need some time alone? Alright, here, try this. No. You did not do this one. It's exactly the same but different. So here they want you to do it for continuous compounding. Now here, well, you guys do it the easy way, and I'll do it the what was it? 1 over n to the, is it nt?
It's RT this time.
N.
No. It's RT. It's RT. Or it's RN actually.
yeah, it's RT.
It's RT.
For it's PE and then to
RT.
the N from part.
It's 14,918.
Yeah.
Wait, RT?
Oh, that one is NT. Yeah.
So let's see here. Let me try this real quick.
That one. Yeah, but he's gonna do it that way.
No, n is number of times.
420.
I should only have the t in there, right?
The continuous one, yeah.
Why did I go to 0.25 here?
Because of the 0.08 divided by 4.
Yeah.
And then you added it to
0.08 divided by 4 is 0.02. So it'd be 1.02.
I was trying to convert it to the other one. So hold on. This is it's p to the e, p to the rt, right?
Yeah.
So that means it should be p to the e rt. This is going to be 1 plus 1 over n to the nth, right?
Yeah.
So I should have an n. But we can't because we don't have a number of times.
Yeah.
Because it goes on forever.
It's just RT.
Yeah. Because n would be infinity and we can't plug in infinity. Okay, so we have to use the rt.
Yeah, you can't use the other one.
Okay.
It's PERT.
Like, what's it?
Oh, at the end? This will become 10,000 e to the 0.085. Yeah, we can't plug in the formula. I tried to, but obviously you can't because n goes to infinity, and there's no number large enough for me to plug in for infinity. Now I could put in a really, really big number and try to approximate what that is, but this would be exact. I'm gonna do it with my calculator.
That's what we just did.
No, I want to try it the other way because I know my calculator can handle a big number. So 10.
Should I do it?
Yeah, 1.46 make it
2.246. Who said we were rounding?
Yeah, this would be approximate at the end.
It'd be 14. It'd be 14.
What'd you get?
14, 918.25.
0.25?
Yeah. I rounded.
So here's a good question. We did 5 years, right?
Yeah.
Continuous comp, I mean, it never ever stops. Is that much of a difference between doing it quarterly?
Yeah. Not too much.
It's about $100. Probably less. It's a little bit less than $100. So, even if you thought about it, I mean, it sounds good in theory, right? Like, man, never stop getting interest. It's really not that much of a difference. That's it, guys. That's all I have.
Really? It's only $58 and like 77 cents.
I still want to do it with the